Good morning. Today we are going to be lecture number 4 on beams. But in first lecture we have seen theory part. In the second lecture we are with some part which problems we have to solve, and we have considered one problem where we have calculated design bending strength. Then we have another problem again, design bending strength. But there we are with UDL, capacity of UDL, and that is safe UDL. That was third. Now we are with fourth. And now fourth we have, if you will go in this playlist, that is of steel structure, and this we have lecture number 25, where we have laterally unsupported beam. One problem which was solved there in detail, and that type of problem we are going to consider over here. But go through this problem, then you have idea how we have to go in detail with this. This is revision, so I cannot go in detail. Same as explained in video number 25 in playlist steel structure. And second, we have that is on laterally supported. Actually, we have this as 27, but this is design, so that we will go in next video. So now you have to go this lecture number 25 for this laterally unsupported beam. Now we will go with the problem. So again, we are with section 8 only, where we have design of member subjected to bending. And here we are going to use clause number 8.2.2, which is related with your laterally unsupported beams. Laterally unsupported beam. So now we will start with, so we will first go with the problem. So we have determine bending strength of ISMB 450. ISMB 450. The beam is laterally unsupported. And the span of beam is 5 meters. And the span is 5 meters. Then beam is simply supported at both ends. Beam is simply supported at both ends. Supported at both ends. Also calculate A part, we have UDL throughout the span. UDL throughout the span. And second, concentrated load at center. So we have to go with this problem. So now we will start with, so we have solution. We have step 1, given data. We have given ISMB 450 at 72.4 kg per meter. I am in college, and from college I am recording this, so you may have some noise. Then we have beam given, which is laterally unsupported. It laterally unsupported. So when it is laterally unsupported, its bending strength reduces because some of the strength that is utilized for to develop resistance in lateral direction. So laterally unsupported, and then we have span 5 meter, simply supported. So this data, this is given, and we have to find out UDL and concentrated load. Then we have step 2, properties of section. In most of the problems in design of steel structures, we have these steps as same. So we have H equal to D equal to 450 millimeters. Then we have BF 150 millimeters. Then we have TF 17.4 millimeters. Then we have TW 9.4 millimeters. Then we have ZPZ 1533.36 into 10 raised to 3 millimeter cube, and then RYY 30.1 millimeters. So I have taken same problem so that you can compare how the change in the strength of the member. Now this extra value we require in laterally unsupported, which is RYY 30.1 millimeters. Then we have step 3. We have classification of section, and that classification, again we have table 2, classification of section, table 2, page 18, table 2, page 18, and here we have B by TF. Already these things we are with both the problems. BF by 2 upon TF, which is 150 by 2 upon 17.4, 4.31, which is less than 9.4, where we have epsilon is equal to 1, flange is plastic. Then we have to go for D by TW. So we have D by TW, which is again same, H minus 2TF upon TW, which is 450 minus 2 into 17.4 divided by TW is 17.4. That comes 44.17, which is less than 84, and therefore wave is also plastic, and therefore section is plastic, and therefore beta B is 1. Section is also plastic, and therefore beta B is 1. And then we have step 4. Step 4, which is bending strength. And as we have beam is laterally unsupported, we have to go clause number 8.2.2, page number 54. And from this clause, we have formula MD is equal to beta B ZPZ into FBD. Now we have beta B already one, we know FPD, we have to find FBD. Now we have two methods to calculate FBD value. So we have one method, that is, I can write first method. You have to use in exam one of the two. First method, which is by using formula. Using formula. Or another method we have, that is using, we have second using tables 13a or b, and then we have 14. So by using these table, we can find value of FBD. Both these are to calculate FBD. Now we will go with first method, and that method we have based on formula. So I will write first method. Now in this, we have to find FCRB by using formula 1.1 pi square E divided by, I think this is given on page number uh, page number 54 only. So upon LLT by RY, LLT by RY whole square in bracket 1 plus 1 by 20 in bracket LLT upon RY, LLT upon RY divided by HF upon TF, and square of this, and then whole square we have 0.5. Now we will start with, so we have to find out from this value of FCRB. Now LLT, we have effective span as it is simply supported. So we will say it as L, which is 5000 millimeters. And RY already we have seen 30.1 millimeters. And from this we will get LLT upon RY, which is equal to 5000 upon 30.1, and we will get this value 166.11. Then we have second HF upon TF. HF we have center to center distance between flange, center to center distance between flange, and therefore we have H minus TF, and H we have 450, and TF we have 17.4, and from this we will get value of HF 432.6 millimeters, and therefore we will get HF upon TF, which is equal to 432.6 upon 17.4, and this value we will have 24.86. And we will substitute these values in FCRB, and from this we will get 1.1 into pi square. Value of E is 2 into 10 raised to 5. LLT upon RY we have 166.11 in bracket 1 plus 1 by 20 in bracket 166.11 divided by 24.86 whole square to the power 0.5. And from this we will get value of FCRB 141.48 Newton per millimeter square. Now after this, we have to find out value of lambda LT. We have lambda LT equal to root of Fy upon FCRB. These all formulas are given on page number 54, 8.2. So 250 divided by 141.48, and we will have this value that is equal to 1.33. Now knowing this value of lambda LT, we can find value of phi LT, and we have this value of phi LT is equal to 0.5 in bracket 1 plus alpha LT in bracket lambda LT minus 0.2 plus lambda LT square. And then we will substitute values in this 0.5 in bracket 1 plus lambda LT 1.33. Sorry, alpha LT, we have already taken value of alpha LT, we have 0.21. This already we have mentioned for rolled section 0.21. Lambda LT is 1.33 minus 0.2 plus 1.33 square. And from this we will get value of phi LT 1.503. Knowing phi LT, we can find XLT, and XLT we have 1 upon phi LT plus phi square LT minus lambda square LT to the power 0.5. And then we will substitute values in this. 1 upon phi LT we have 1.503 plus 1.503 square minus 1.33 square to the power 0.5, and this value comes 0.45. And final formula to calculate FBD value, we have FBD is equal to XLT Fy upon gamma m. And then if we will put values 0.45 into 250 upon 1.1, therefore we will get FBD equal to 102.27 Newton per mm square. So this is by using first method. Now we will go with second method. Keep in mind, in exam you have to use only one method. You can go to the table or you can go to the formula. So second method. And in second method, for this problem, we are going to use 13A because it is for rolled section, and for welded section, we have 13B. And then we have to use 14, which is for FCRB. 13A we have for FBD. Now already we have calculated LLT upon RY. So this is 5000 divided by 30.1. This comes 166.11. We have also calculated HF upon TF. HF we have 450 minus 17.4 upon 17.4, and it was 24.86. Now we will go to the table 14. And in this table 14, we have LLT upon RY, and then we have HF upon TF. Now LLT upon RY, we have 160, and then we have 170. Now HF upon TF, we have 20 and 25. Now for 20, we have this value 173.9, and then this value for 25 148.2, then 161.4, and second value 136.7. Now first we will calculate this value. So we have this value, I will write one number. So one number value we will calculate in this fashion, that is 173.9 minus 173.9 minus, because it is reduction, 142.5 divided by 25 minus 20. We have taken 173 means base 20. So we have to take 20 So 24.86 minus 20, and we will get first value, that is 148.92. Then we will calculate a second value over here. So we have second value. So second value I can write 161.4 minus 161.4 minus 136.7 divided by 25 minus 20 in bracket 24.86 minus 20, and we will get this value equal to 137.39. Now I will use another color so that you can understand these values. So we will have first value 148.92, and we have second value 137.39. No, sorry, we are not being these values. So we have 148.92, and we have another value 137.39. So this is our first value, this is our second value, because these values we have calculated for 24.86, and now we are with 160, 170, and then we have this as 24.86. We have values as 148.92 and 137.39. Now we have to calculate value that is for 166.11, and then we can find this value, that is 148.92 minus 148.92 minus 137.39 divided by 25 minus 20. Base we have taken 160, so 166.11 minus 160, and if we calculate this value, we will get it as 141.30 Newton per mm square. So value we have over here 141.30. So for these combinations, LLT upon RYY 166.11 and HF upon TF 24.86, we will get value of FCRB that is equal to 141.30 Newton per mm square. Now using table 14, we will calculate FBD, table 14. And then in this, we have FCRB. So that is, and then we have for FY 250 value of FBD. So FCRB we have 150 and 100. And then values against these are 106.8 and 77.3. And we are interested to calculate value that is for 141.30. So 141.30. For this, we are interested with the values. So 106.8 minus 106.8 minus 77.3 divided by 150. No, sorry, this is not 25 minus 20, because we are with 148.9 to 137. So we have to use these two values. So please make correction over here. This is, here we have 170 minus 160. Because here also we have taken 160. So that correction you have to make over here. So I come to know, because here we have 150, 100. So we have 150 minus 100. In this base, we have taken 106.8, which is 150. So 106.8 minus 100. Sorry, 106.8 we have. No, sorry, here we have to go for base, we have taken 150, and our FCRB value we have 141.30. So we have 150 minus 141.30. Whatever base we have, that we have to consider over here. If it is lesser than the actual value, then we have to subtract. If it is greater, here you have greater, so subtract it. So likewise, we have to go for this. And from this, we will get value for FBD. And this value comes equal to 101.67. So you can see very little difference. If we will see, this is by second method. And first method, if you remember, we have value that is 102.27, which is by first method. First method. So it is not even 1% also. So you can use any of this. This is, you can say 102.27. So this is our step number 4. Now we will go to step number 5, where we have to find bending strength. And as I mentioned, we have to go to 8.2.2, and we have MD is equal to beta B is 1. ZP we have 1533.66 into 10 raised to 3 into FBD we have 102.27. You can take another value also, and from this we will get 156.82 into 10 raised to 6 Newton millimeter, or 156.82 kilonewton meter. Now we have first part, UDL we have to find. Then we will go for UDL, not mention excluding, including anything. So we will just find value of WU. We will not subtract self weight. We will keep as it is. And we will write there. So we have WU, span is 5 meter. So we have MU is equal to MD, WUL square by 8. And from this we will get WU is equal to 156.82 into 8 divided by 5 square. And we have this value 50.18 kilonewton per meter, including self weight. If we have to subtract self weight, then you have to go, that is kg per meter into 9.81 upon 1000, that you will get in kilonewton per meter self weight, and then you have to subtract it. Then we have another value which is PU, and this is 5 meter. It is at in center 2.5, 2.5, and then we can have MU is equal to MD is equal to PUL by 4. And from this we will get PU, that is equal to 156.82 into 4 upon 5. And we have this value 125.46 kilonewton. Actually, this is not exact. So we have self weight of this, and that we have to subtract. And then we have to go actual value. Then we can say M due to self weight, that is equal to WUL square by 8. And W we have 72.4 is its kg per meter. Convert into Newton per meter. Convert into kilonewton per meter into 5 square upon 8. And this value comes 2.22. Sorry, this is formula. WL, this is WU. It comes 2.22 into 5 square upon 8. No, sorry, this value, total value, this is self weight, and this value comes 72.4 into 9.81 divided by 1000. It comes 0.71. And then we have into 5 square upon 8, it comes 2.22 kilonewton meter. Therefore, we will get, now we can write MD becomes 156.82 minus 2.22, and it comes 154.6 kilonewton meter. And then you can equate it. Mu is equal to md PUL by 4. And then now we have, therefore, PU, it becomes 154.6 into 4 upon 5, and it comes 123.68 kilonewton. So this is exact value. This we can say, this you can say that is 125.46 by including self-weight. So likewise, we have to solve the problems related with laterally unsupported beam. I already mentioned we have one problem that is in our playlist, and from there you can see that one. So now we will stop here.